All right, today let's talk about slope. So again, I've got these notes already in a Cornell Notes format. With Cornell Notes, I want y'all thinking about the objective, the topic, the essential question as a bit of like a title of a book. You've got your chapters on the left side, kind of guiding you through the parts of your notes. And then on the right side, you've got the body and the actual material of your notes. So let's zoom in a little bit, talk about what we are going over today. So again, the topic today is slope. Our objective is to be able to define and calculate the slope of a line by plotting 2 points on an XY coordinate plane. And the essential question I want you all to try to be able to answer in the summary at the end of your notes today is, how do I determine and interpret the slope of a line on a physics graph? So let's move into chapter 1. What are the key parts of a graph? Well, this should be a little bit of review, but let's go over the parts of a graph. So we've got two axes on a graph. We've got the x-axis, which is right here. And we've got the y-axis, which is going vertically. And I always struggle to draw nice and straight vertical lines. But so we've got the y-axis, again, is the vertical line. And we've got the x-axis, which is the horizontal line. We also have a line going on these axes. Now, it's not always going to look like this. It can be straight. It could be curved. It could be, a sinusoidal graph, which is going up and down, kind of looks like a wave. But for our purposes right now, we are just going over a straight line, a linear line for today. So we'll be talking about linear line graphs. So on any line graph, we have an x-coordinate, which lines up with where it sits on the x-axis for a specific point. And we have a y-coordinate, which for that specific point is going to line up where it sits on the y-axis. So these are going to be points that you will need to remember for how we are going to use them for calculating the slope of a graph. So our second chapter today is, what is a slope? How do I calculate and interpret the slope of a line? So I'm going to zoom out a little bit so y'all can see this a little bit better. Make sure it's all in the frame. Okay, so the slope is, and I will underline this because this is an important vocabulary term right here. I'll even highlight it as well. So the slope is kind of just the steepness of a line. You might have heard the saying rise over run. So if we zoom in a little bit, you can see that on this graph. So we've got our rise, right? How much is it moving up the the y-axis? This is our rise. And we'll highlight that in green, okay? The rise is going up the y-axis, and then we've got the run. How much is it moving across the x-axis? So our equation that you all should be super, super familiar with. This is one you should always, you don't have to memorize it, but you should definitely make sure you have this written down. This is our equation for calculating the slope of a line when we know 2 points. I will shade that in. Okay. So in other words, we could also write this if we wanted to. Again, the slope, the definition of slope could be the rise of a line over the run. So we're just looking at the rise in terms of the y-axis as it should be. we will write that m is equal to rise over run. So how much is it increasing or decreasing across the y-axis over how much it is increasing or decreasing across the x-axis. So you can see based off of this equation, we have two different coordinates that we are basing our calculations for slope off of. We have the x1, y1 coordinate, which is right here. Okay, x1, y1, and then we have the x2, y2. We are plugging those respective coordinates in to our equation. So we've got x2, y2 right here, and then we've got our x1 and our y1 right here. So you're always going to be subtracting your x1 and your y1, again right here, from your x2 and your y2. We'll move on. So we've got a couple different types of slope. So I just showed you a line with a positive slope. In other words, if I can change the color palette so y'all can see this a little bit better. Okay. So a positive slope, right? We've got a positive rise and we've got a positive run. All right, so I'll write that m is positive rise over positive run to give us an overall positive slope. We could also have a negative slope. In this case, we still have a positive run, right? This line is still going this way, so our positive run, but our line is going down, which means we have a negative rise. So if we're looking at our slope equation here, we've got a negative rise because it's sloping downward, but it is still a positive run. Okay. We could also have zero slope. In other words, the line does not have any steepness at all, right? We are on a flat surface. Okay, we still have our run happening, but we have zero rise. So if we plug that into our slope equation here, we have our run, but our rise is zero, which gives us an overall zero slope. All right, the only time that we would have just not even a zero slope, but no slope at all, right, an undefined slope, is if we have a rise, check, but no run. So in this case, m is equal to our rise, but our run is zero. And if you recall from your math classes, we cannot have this. This gives us an undefined number, right? So whenever we have zero in our denominator of a fraction, that does not work. Okay, that gives us an undefined slope. Go ahead and just underline that. Make those all right there. Okay, so those are our types of slope. We have positive, we have negative, we have zero, or we have undefined. Those are what those lines look like for all different types of slope. Let's talk about the steps we would take to solving our slope. So these are our 3 steps to solve the slope. Again, I want y'all to pause the video at any point if you need to take some extra time to write those in your notes, because your notes should look like these. So the first step is to label the coordinates, all right? So if we have a line, we were looking for 2 coordinates. It could be any coordinates you want on the line, but you need to label them as x1, y1, and x2, y2. All right, so in this example here, I'm going to zoom in a little bit more. I've got my graph here. So I will say that, let's make this 1, 1 coordinate right here. We'll say that is x1, y1. And then we have a second coordinate, which is 3, 2. We'll make that x2, y2. Okay, let's move to step number 2. I'll zoom out a little bit so y'all can see step number 2. Step number 2 is to plug the values of the coordinates into the slope equation. Okay, so we've got our slope equation, which we remember is m is equal to y2 minus y1, x2 minus x1. So all we're going to do is take those numbers and plug them in for our values there. So we've got our, let me change this back to red. So we've got our first 2 coordinates, 1, 1. That's going to be our x1 and our y1. So I'm going to plug those into my equation right now. I'm going to do that in black. So our x1 coordinate is right here. It is 1, right, minus 1 right here. And our y1 coordinate is right here, and that is also 1. Then we've got to plug in our second set of coordinates. So y2 and x2. And those are located right here. So we've got our x2, which goes right here. Right? And then we've got our y2, which is going to go on top of our x2. All right, now we've got those plugged in. If we look at our last and final step, solve for slope using order of operations. Okay, so we've got everything plugged in here. Now remember, when we have 2 or more things in the numerator and 2 or more things in the denominator, we are treating these separately. So I just like to make a mental note. These are separate. You can draw parentheses on them. So what we've really got is 2 minus 1 in parentheses divided by 3 minus 1 in parentheses. So I'm going to solve those separately. So we'll start with this parentheses up top in the numerator. 2 minus 1 is equal to 1. Then we'll go on to the denominator. 3 minus 1 is equal to 2. All right, so we've got a pretty simple fraction. Slope is 1/2. We could also simplify this even more if we wanted to plug this into our calculator and get it into decimal form. 1/2 in decimal form is 0.5. There are no units for slope. So we are done with this problem. That is our final answer here. So our slope for this line right here, and I will highlight it in yellow, is m is equal to 0.5. I'm actually going to undo that highlighting because you cannot see the answer anymore. So m is equal to 0.5. That is the slope of this line following all these steps right here. Okay. So I'm going to zoom out so y'all can see all of the notes again. I want y'all to write your summary, your 1 to 2 sentence summary about what you learned. Try to answer the essential question up there as you write your summary. And I look forward to discussing this in class.